Welcome back to Systems of Equations for Math 021. In this video, we're going to look at our last two examples, examples 7 and 8. Looking at example 7, we have 6x minus 3y equals 3 and 2x minus y equals 4. So I'm going to use elimination in this one. Again, we have things in standard form. It just makes it easier since things are lined up. So if I look at my x's, okay, 6 and 2, well, I could easily get those to have the same coefficient if I multiplied that second equation by a negative 3. That would get them to have the same coefficient, and when we combine, the x values would go away. So let's look at y and see if that one would be just as easy. So if I look at the y, I have negative 3 and a negative 1. Again, if I multiplied through by negative 3, then I could combine like terms and my y would go away. So it really doesn't matter on this one which one I pick. I'm going to pick the x, so I'm going to multiply through by negative 3. I'm doing a negative, so the signs will be different, so that way when we combine, things will actually cancel out. My first equation is going to stay the same. 6x minus 3y equals 3. My second equation will become negative 6x plus 3y equals negative 12. Combine our like terms, 6x and negative 6x. We'll subtract out, I have 0. Negative 3y plus 3y will also subtract out, and I'll have 0, equals 3 and negative 12 would be negative 9. So you can see on the left-hand side, I didn't leave that empty, or have 0 on that side. Excuse me. So we would have 0 equals negative 9. Not any variables, just the number 0. Okay. Now, 0 actually does not equal negative 9. This is a false statement. Very similar to with our linear equations. When we have a false statement, that means for this one, we're going to get no solution for our answer. Okay. There's no plugging back in because there's no number that's going to work. Okay. So if we get a false statement, we end up with no solution. All right, let's look at example 8, our last example for this lesson. We have 2x minus 3y equals negative 2, and 5x plus y equals 12. Looking at our x variables, coefficients, 2 and 5, well, I could turn that into 10, but I'd have to multiply both the top and the bottom equation. I don't want to have to do that if I don't have to. I can, again, but let's see if the y values would be easier. So I have 3 and 1. Well, that means I could multiply that second equation by 3, and the y's would cancel out. So I'm going to go for the y variable there. So I'm going to multiply that second equation by 3. My first equation stays the same. 2x minus 3y equals negative 2. My second equation will become 15x plus 3y equals 36. Combine our like terms. 2x plus 15x is 17x. Minus 3y and a plus 3y will subtract out. And 2 and 36 will be 34. Divide both sides by 17. X equals 2. Now we need to plug that back in to find our y value. I'm going to use my first equation today, or for this one. Actually, no, I think I'm going to use the second equation since y doesn't have a coefficient. So we would have 5 times the quantity 2 plus y equals 12. And since y doesn't have a coefficient here, there's going to be less steps I have to do, which I like. 5 times 2 will give me 10 plus y equals 12. Subtract both sides, 10 on both sides. Y equals 2. So my ordered pair for number 8 would be 2, 2. Now it doesn't matter which one you plug back into. If you plug back into the first equation, you get the same answer. If you used substitution instead of elimination, if you did it correctly, you would get the same answer. So there are multiple ways you can solve these. I'm just showing you the easiest for me and hopefully the easiest for you.